Welcome to the Troxel Podcast. I'm Evan Troxel, and this is a Campfire Series episode, the kind where we slow things down. So pull up a chair as we trace the long arc of a career that quietly reshaped the profession. Today I welcome Neil Katz. Neil is widely credited as one of the original pioneers of computational design and architecture, long before the term existed, back when geometry, code, and curiosity were the tools, not software brands. From programming on an Atari 800 to early mainframes at SOM to writing custom automation before parametric was a word that architects used, Neil has lived every major technological shift our industry has experienced from the inside. But this conversation isn't a software history lesson. It's the story of a mind shaped by geometry, morphology, and systems thinking, and how that mindset influenced everything from early CAD and BIM workflows to behavior-driven design, fabrication, and today's AI conversations. Neil shares how SOM approached technology decades ahead of the curve, what it actually took to make those shifts stick, and why the real innovation was never the tools. It was how people thought. If you're a longtime fan of Neil's work, this episode connects the dots across his entire career. And if you've never heard his name before, this is your origin story. And if you care about where architectural technology came from and where it's headed, this is one you won't want to miss. As always, there's a ton of additional context and links in the show notes available in your podcast app if you're a supporting member of Troxel Plus, or at troxel.co if you're not. If you like the work I'm doing here, it would mean the world to me if you would consider supporting this endeavor financially. Check out trxl.co to learn more. Just click one of the join links. I came away from this conversation both nostalgic and energized, so without further ado, I bring you my campfire conversation with Neil Katz. All right, well,
Great.
Neil, great to have you. Thanks for coming on the show.
Thank you, Evan. It's great to be here.
It was great to meet you in New York City as well, in person for the first time. Obviously, I've heard your name a lot over the years, and I mean, you definitely have how would you describe your career? Is it illustrious? Is it like what? How would you?
I would never describe it that way.
I visited a building that you did in BIM, a very famous building, when I was there, and that's what I think of when I think of you. So what comes? Is it just a normal career for you? Is this run of the mill architecture?
Well, no, not at all, actually.
Good.
And I talk to other architects and learn about what they do. And, we have a big office. I see them work. And I feel pretty lucky that I'm able to do what I do, because I really do love it.
Well, let's go back to the beginning, Neil. And so I like to start. This is a campfire episode where we're all going to pull up chairs and get a nice warm beverage and sit around the campfire now, and kind of wax nostalgic about where architecture has come over all these years. And so when I say let's start at the beginning, what does that bring to your mind?
So I've known I wanted to be an architect for a long time, since high school. And I never knew an architect and, had assumptions about what architects do. The reason I chose that field is because I loved math and I used to love to draw. And people would tell me, with that combination, you should become an architect. And I don't know if they knew any better than I did, but that was the advice I got from them. And I said,
I
okay.
tend to think not. I think that like those high school counselors and stuff who all said that architects needed to know math and take all the math classes were really thinking about engineers for the most part.
Yep.
And they don't really know even the difference between architecture and engineering. It's like, well, that's
true.
buildings. Obviously, they're tied at the hip. And so in high school, I took architectural drafting for 4 years. And so it was even before that I knew I wanted to be an architect. And I think it was because we would go visit the bookstore in the mall, and I would always go to the magazine rack and pull out the plan magazines, right? All the floor plans. Some point I laid eyes on the Roby House by Frank Lloyd Wright, and I was like, whoa, this is different. When you thought you wanted to be an architect in those early years, was there something like that where it was like, because you said you didn't even necessarily know what architects did, but what was in your mind back then that you thought architects did do?
I thought it would use skills in math and drawing, and I thought that I'd be, using those things in the work that I would be doing, and I am, but not in the way that I guess I had imagined back then.
And if we think about our past in architecture, drawing meant May lines or T-squares, and it meant parallel bars, it meant whatever. Like it was very different than obviously the evolution that you and I have experienced in this field.
That's right. And, you know, when I was in high school, it was, we didn't have any architecture classes in my high school. So I was doing those things like technical drawing on my own. I would pick up books about that and just try it.
Nice.
But I was really into, when I was in high school, academics. So in addition to math, so interested in science, all of the sciences, physics and chemistry and biology.
Nice. Did you have really good teachers back then?
I did, yes.
Yeah, right. I mean, that makes a huge difference, right?
It does. Yeah.
Because you could really not like those subjects just based on the teacher you had.
Exactly.
Yeah. So to be able to kind of foster that with good teachers, and that's amazing. I had a very similar experience to that. It was like I like all of these subjects.
Yes.
I was very good at all of these subjects. School wasn't particularly difficult, but at the same time it was challenging in that we were just being exposed to so many new things. And my dad was a scientist, so I always wanted to be one of those too, right? Chemistry. He was a chemist and a biologist, and it was like I like all of this, and I had great teachers, which really helped.
Yeah.
So my architectural drafting class, we actually got a CAD program when I was in school, and that program was called Generic CAD. Generic
I think I've
CAD,
heard of that.
and it ran on my dad's K Pro, 386 at the time, and it was slow and cumbersome. But we also had an 8.5 by 11 pen plotter in the back room of our drafting class. I was the very first person to ever get to try to figure out how to use that, and I mean, to just talk about kind of the changes that we've seen from.
Yes.
And at the same time, many things that aren't that different, right? So it's interesting. So take us like through the history of you becoming an architect from high school on.
Yeah. So, well, just one thing about computers. After I graduated from high school, but before I started college at Pratt, I was interested in computers, but had never used one. And I bought an Atari 800.
Nice.
So I think I go back a little bit farther than you did.
Yes.
And just learned how to program in BASIC and was amazed at the things that this kind of tool would be able to do.
Right. It's interesting to think back to computers where you turned it on and the computer was meant to be programmed. Like that was what people bought computers for. It was not to run applications. It was to make something and to start with code and commands, right? It was very different. It was a thing that took a lot of effort and process to kind of go through and make it do things. And then, obviously spreadsheets and things like that came along over the years.
Right.
But in the beginning, you just got a prompt and it was like, okay, I'm going to start programming.
Right. Exactly.
So where did it go from there?
Well, then I started my 5-year program in architecture at Pratt Institute. And one of the first classes I had was called Technics. And it was sort of an introduction to geometry for architects. And it was required. So all incoming, freshmen in architecture were required to take this class. And the teacher that I had was Ann Ting. And she, I didn't know it at the time, but she worked with Louis Kahn.
Okay.
And she's responsible for a lot of the geometry behind his work. She was amazing.
Now that you've said that, I recall, he could not have accomplished what he accomplished without her.
Yes, that's right.
Right.
Absolutely.
Wow.
And
so she was teaching at Pratt in New York City, and that
Yep.
was your first experience in kind of geometry.
That's
basically,
right.
in college. Wow.
That's right. Well, besides, geometry in high school, which I love.
But architectural geometry
Yes,
more than theorems and proofs. Yeah.
That's right. Exactly. Yeah. And she was also teaching at UPenn. That was a primary, I think, teaching job. And once a week, she would come to Pratt to teach this technics class.
Very cool.
And
his office was in Pennsylvania, right?
In Pennsylvania,
in Philadelphia.
that's right. In Philadelphia,
Yeah.
exactly.
Right.
That's right. And so her class really inspired me. And I said, while I was in her class, I'm in the right place.
Nice.
But some of the other classes, not so much. And I wondered if, architecture was the right thing for me.
Mm.
Thought maybe because of my interest in math and sciences in general, and because I had such an academic experience in high school, a very positive one, that maybe engineering would have been a better choice.
Interesting.
And I asked Aunt Ting about that, and she encouraged me to stick with it.
Interesting. And why did she encourage you to stay? Because she saw something, or it was just like, well, let's just wait a little bit and tease this out kind of a
I
thing? Or?
think I got to know her very well,
Mm.
because I just loved her class.
Hmm.
And I think she did see in me that it would be something that I could pursue in
Yeah.
a good way.
Yeah, I mean, you think about kind of the bifurcation of design and engineering, and a lot of architecture schools really focus on that design side, which of course is
Exactly.
steeped in geometry and things
Yes.
like that.
Yes.
But
Yes.
but you also think about like the merging of kind of that analytical mind applied to design,
Hmm.
and it's still totally makes sense, right? In
Yes.
architecture. Yeah.
That's right. That's right.
Wow. So you loved that geometry class, and how did that play out when it kind of came to studio time and things like that?
Well, my projects were very geometry focused.
Mm.
I think more than other students in my classes.
How
I would
so?
always start with the geometry,
Okay.
with the geometric base, as part of my design. And I think teachers, and I think it was different, noticeably different from the way that other students were approaching their projects.
Nice.
But the
So
teachers understood.
they
They
did.
let me do it.
They let you do it. Yeah. Nice. So, and can you explain just for the audience, like when you were in school, what was kind of the basic tools for an architecture student back then? Was I assume a lot of physical models, a lot of
Yes,
drawings. Yeah.
physical models and drawings, sketches, and manual drafting.
And how important was the physical modeling side of it to for you as a student?
I loved it. I mean, it
Yeah.
varied by studio. Some
Mm.
professors, encouraged physical models more than others.
Mm.
But I enjoyed building physical models.
Yeah, for me, I had built a lot of models before I went to architecture school, but they were
Hmm.
like airplanes and boats.
Right? Yes.
There was plastic models.
Same
And
here. Yes.
going into school or into architecture school, it was, I mean, the whole idea of a study model and a
Hmm.
finished model
Hmm.
and having lots of study models and tearing them apart and putting them
Yes.
back together,
Hmm.
but also just think spatially. Like that was such a key back
Exactly.
then to
Mm.
understanding spatial relationships and even materiality, but light and shadow and thing and the way you could pick it up and I mean this we used to do this in our hands before we did it on computer screens,
That's right.
right?
Yes.
Now
Exactly.
it's on a 2D plane on a computer
Yes.
screen, or maybe you're doing it immersively in VR, maybe, but probably
Hmm.
not, right? It's like
Hmm.
it's still pretty rare, but that that to me was really a formative time of becoming an architect, and spatial thinking was those study models and those final models.
Yes. 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 Um, we also took classes. I mean, no, there were no computers in the school when I started at Pratt. Later there were, and I could talk about that in a while. But some of my favorite things to do in some of these like drafting classes were the more complex drawings,
Mm.
axonometrics,
Mm-hmm.
perspectives with shadows,
Mm-hmm.
like stairs with shadows. I love
Mm-hmm.
that.
Mm. Yeah, I think back to Richard Meyer
Hmm.
drawings, right? Really high contrast, black
Yes.
and white,
Hmm.
figure
Yep.
ground kind of drawings. A lot. That's where we would study
Hmm.
Richard Meyer's axonometrics to really learn
Yes.
how
Hmm.
axons were made.
Yep. Yep.
Even recently, with just the recent passing of Frank Gehry,
Hmm.
and kind of looking at some of the times when he put his work on display. Obviously, a huge model shop, but also the
Yes.
drawings were incredible,
Hmm.
absolutely incredible, and large format, and just enormous
Yes.
things. Not
Yes.
just sketchbook kind of
Hmm.
drawings, right?
Yep.
But
Yep. Yep. Hmm.
wow, yeah, incredible stuff.
As much as getting the drawings to look right with contrast and line weight and things like that, to be able to visualize and communicate with the drawings, the 3D aspects of what I was modeling in a way was interesting to me.
I just read a recent thing about the old Kohinoor rapidograph ink pens, right? Which I have a set right over here that might from school that haven't been used and they probably don't work anymore. But interesting thing about the line weights and how they were designed based on being reduced. So the line weights were exactly twice as big as they needed to be when those drawings got reduced by 50% or whatever. And I thought that, I learned something new just last week about the old ink pens that I learned how to draw with in school. Yeah, really interesting.
Yeah.
So where did that lead? I'm curious how all of this kind of made its way to you guys actually getting computers and starting out using those and applying them to architecture.
So I had my Atari 800. And I was trying to use it as much as I could for design classes. So I would, in BASIC, learn how to create graphic models, or at least graphic representations of things that I had in mind on the screen. They were 2D.
Right.
I don't think
and
I was able to...
type in the coordinates, right? Like you would draw vectors by typing in the coordinates in the right order for it to draw.
Yep. And I remember... a couple of times I actually would lug my computer, right, my Atari 800, into school and present what I was doing with the computer to my class on the screen.
Right. Yeah. Were there ways to print out? Did you have a dot matrix or anything back in those days to print out those images?
I didn't know.
Yeah.
It had to be on the screen.
Yeah. Right. And it was a monochrome screen, right? Did you have green and white or amber? Not white. Either green or amber.
Right. I think it was green.
It was a long time ago. I'm pretty sure I had an Apple IIe when I was in the 5th grade, and I did what you're talking about, where I would program in the coordinates, and it would draw the lines between those, and I would try to reproduce like the cover of a record album or something by actually laying grid paper over it and like figuring out what the coordinates were, and then transcribing that basically back into the computer. Wow. Very cool. So you would bring your computer in, and what did your professors think when you would do that?
I think they thought it was interesting.
Really?
Yes. Yep.
Because I was thinking they probably were like, get off my lawn, kind of.
I think they were impressed that
nice.
and maybe, looking into the future, that one day, computers would be able to do these kinds of things, and this was pretty early. Wow. But I think they were impressed, and I was the only one.
Yeah.
Not only
I was
in my
projecting
class,
a little bit.
School. Yeah.
I was projecting a little bit there when I said get off my lawn, because that was my professors, and we did have a computer lab, and still, I was one of 2 people who was actually using the computer in the earlier design studios, and it was like they would just kind of shake their head. They wouldn't say we couldn't do it, but they would just kind of have a disapproval. You could just read it in the body language.
Yes.
Because it wasn't how they did it. It wasn't how, and it wasn't what they. Obviously, there's value in drawing by hand and learning the techniques that they learned, and at the same time, things are changing.
Yes.
Not as accepting of that.
That's right. And I had to do that too. It wasn't like what I was doing on the computer replaced what everyone else in the class. I had to do that also, but was able to do this additional thing.
If you look back and think of like where that started with you drawing those 2D lines, do you feel like the evolution of maybe just in the next 5 years from that point, do you think did it feel fast or did it feel slow when you think about what the progression of technology back then?
It did feel fast. When I was in my either 3rd or 4th year at Pratt, they actually got a computer in the School of Architecture. Even before that, there was a computer science degree program at Pratt, and I took some computer classes in different programming languages.
What programming languages? It was like Fortran?
Fortran and COBOL.
Okay. Yeah. And I think that went on for a very long time.
Yes.
Like that.
Yes.
Yeah, for sure.
Exactly. And
wow.
Yeah. So when Pratt got their computer, and I don't even remember what kind it was, but it was a big machine. I think everything was included, including the seat and the monitor and the keyboard. Everything was like one unit. And not that many people were interested in using it. I was, and I didn't have much competition. There wasn't like a long line to to get
Right.
to use it.
Wow. So let's keep going from there. What happened next?
Um, After I took the technics class with Anting, I wanted to continue studying that topic. And the next level of technics was called morphology. And there was a professor whose name is Harestal Alvani, and he taught morphology classes. So I took several of his classes, and it deals with geometry, geometry in architecture, but even more pure geometry, polyhedra, and eh, space filling, things
Yeah.
like that.
Mhm.
And I started to use the computer that we got in the School of Architecture to model some of those. And my professor, not only was I interested in doing that, but my professor was also very interested in how that can be used to sort of push forward some of the research that he was doing.
Nice. And so was that again you doing programming level, or were there any applications to kind of help out in that way early on?
Yep. So that machine was designed for architects. So
Okay.
you actually couldn't, as far as I know, you couldn't program on it, but
Mm,
it had this like early CAD software that
okay.
let you, you know, I guess really early simple commands like
Yeah.
drawing lines between 2 points and copying them and
Right.
creating arcs and circles and things like that.
So was it actually 3D at that point? It have 3D coordinate system, or
It
was it
did.
still 2D?
Yes.
Okay.
No, it was 3D.
Wow. And what was the input? Is it still keyboard driven, or were there mice at that point?
There wasn't a mouse. It was a keyboard, and I forgot what we used to move the cursor. It
There
was,
was there was like a puck. I mean that's not the right word for it, but
yes,
there was. I
yes.
remember there was. Yeah, what was that called? So people can comment on the podcast and
Yes.
let I will look it up after the fact because it's
Yes.
not coming to my mind either. But yeah, it was kind of like a digitizer almost
Yes. Mhm.
that you would use because the early ones that I used were in MicroStation actually
Mhm.
in the first firm that I worked for. But we
Mhm.
also had a big tablet that you did it on top of, and on that tablet you could put a drawing and then
Trace it.
you basically trace it because there was actually a crosshair designed into that digitizer puck that you
Yes.
could use to like move to a position, click it, and then move it over here and click it again, and it
Yes.
would reproduce that into the machine.
That sounds familiar.
Yeah, yeah,
I'm guessing it might have been similar.
yeah. Very cool. So wow, that's really interesting that you were doing basically 3D volumetric 3D geometry.
Yes.
And what year are we talking about here?
This was probably the end of my third year.
Okay, nice. And so after morphology, where did that lead?
Well, I kept going with morphology.
Okay,
So he was developing additional courses, like research courses, all that dealt with morphology.
nice.
And
And was he writing a book about it, or was that you said he was interested in it from a research purpose?
yes, so
Okay,
he was writing books. He was publishing articles in various journals, architecture and mathematics and engineering, like journals or conferences or things like that. And he would ask me to help him create the graphics for those
hmm,
papers that he was writing.
nice. And so, how did those graphics get out of the computer and into his articles and books?
Well, Pratt did have a printer.
Okay,
They got a
so
printer with that computer,
you
so we
could
were
get
able
them
to.
out of there. Nice.
Yes, that's right. And we
Wow.
were also able to export them to like image files. I think they were TIFF files at the time.
Okay. What year, date wise, was this?
It was mid 80s, maybe 83 or 84.
Okay. Wow. And so, were you aware of people outside of architecture using computers for geometric studies or drawing or anything, or was it just what you
Not
had
really.
experienced
Yep.
directly? Okay.
Yes.
Yeah, I'm thinking about like the early stuff that I've seen, Pixar, Ed Catmull,
Hmm.
things. I'm thinking like that kind of stuff. The early
Yes.
ILM days with,
Mhm.
very basic stuff that they were doing in the computer. And obviously that a parallel industry, right? And probably a lot more advanced even back then. But yeah,
Yes.
interesting. This episode is made possible with support from Avail. Is your firm managing architectural, landscape, interiors, and engineering content? Avail's all-in-one content management solution stretches across all disciplines, file types, and content locations so production teams can find everything they need all in one place. Thanks to Avail's desktop application and Revit, AutoCAD, and Civil 3D plugins, teams can consistently find and reuse all types of content from specifications and calculations to 3D models and plans. As a result, standards-compliant models and drawings are easier to create, the documentation process is less chaotic, new hires are easier to onboard, and projects are delivered faster with fewer errors. Visit getavail.com to request a demo. That's getavail.com to request a demo. My thanks to Avail for supporting this episode of the Troxel Podcast. Now let's get back to the conversation.
You know what? One thing that you reminded me of that I hadn't thought about for a long time, I think the software that we were using on this computer that we had at Pratt was developed by people at Brigham Young University. And we were communicating with them about, can we do this or, enhancements to the software based on what we wanted to do that we were not able to figure out using the software.
Oh, that's cool. Right. So they were, I'm sure, interested in how their software was being used as well. I mean, that still goes on today, right? But you were definitely an early adopter pioneer in that way, I'm sure, even from their point of view. It's like, oh, what are people doing with our stuff? And
exactly. That's right.
Very cool. Wow. So you continued with morphology. How far did that go?
Well, I continued until I graduated. And then even after that, and I had already started working at SOM, continued to collaborate with my professor. His name is Haresh Lalvani.
Nice.
So he was continuing to write papers and, publish articles and book chapters and journal articles. And I would not only work on the graphics, but also participate in some of the research that he was doing.
Cool.
And that was on my own time.
And so you guys obviously had built a relationship with you as a student, but were there other people getting interested in this as well in Pratt to help out with this, or I don't know if they got more computers, like how did that evolve?
So while I was there, they didn't get another computer. But there were other people who were becoming interested in not only the research as part of his classes, but even continuing beyond that, like I did.
How foundational to, I mean, I'm kind of guessing what you're going to say right now, but how foundational was this kind of stuff to your career as an architect?
Incredibly.
It had to be, right? I mean, it's like this set you on a course that you never went away from. Right.
That's right.
Absolutely incredible. And it just seems like right place, right time with your mind and what you want and your interests and and your professors. It's just kind of like this magic coincidence of all of those things coming together to set you on this path, right?
That's right. Exactly.
Yeah. Wow.
Yeah. And it's still, I'm still doing research in morphology. My professor is still teaching at Pratt, and a couple of years ago, I also started teaching morphology at Pratt.
Wow. Jeez, that's incredible. So how long you said your professor is still teaching there? So how long has he been teaching there now?
Maybe 45 years.
Yeah. Oh my gosh. Never going to retire.
That's right.
Wow. Right. It's super interesting. So you said by now you're working at SOM. Can you kind of talk about that process of how you got hired there and how you went about that? And I would love to hear that.
Yeah, it's interesting. So the dean at Pratt, when I was there, was friends with one of the partners at SOM. And they were looking for interns to... So SOM had a mainframe computer, right? And people who were using the computer, and it wasn't everyone in the firm, of course, it was just maybe a dozen people. would be creating their drawings and models during the day, but they couldn't print anything during the day. Everything had to be printed after hours.
Because it basically took up the computer. Like that's all the computer
Exactly.
could do at that point, right? So you
That's
couldn't
right.
use it for anything else.
That's exactly right.
Can you explain what a mainframe is for those younger listeners who have no
Yes.
clue what, because now a computer way more powerful is in your pocket all the time, right?
That's
So
right.
can
Yes,
you,
yes.
you talk about what that was and maybe even if you know how much it cost back then?
Yeah. Oh, I don't know. Millions of
A
dollars,
lot.
I'm sure
A
of
lot.
that.
Millions
A
of
lot
dollars, right?
Yes, yes, yes. But there were these huge computers in a room by themselves, which had to be climate controlled. So it was always cold. It was air conditioned in that room. And some companies, I think, had rooms not too far from those mainframe computers where they would have terminals. So people using the computers would all sit together, and the terminals wouldn't have any computational power on their own, but there would be wires connecting them to these mainframe computers. At
Yeah,
SOM, they were distributed. They weren't
okay.
all located in the same place. They were distributed throughout the office.
We had that in school. It was called the VAX, and I don't remember what VAX stands for, but it was terminal. Everybody had there was a room full of terminals, but they were
Yes.
all just connected through
Hmm.
probably really basic networking cabling
Yes.
back then
Hmm.
to
Hmm.
machines that filled the basement of the library, like
Yes.
enormous
Yes.
amount of computing, right? So,
That's
which,
right.
which is again not a lot of compute, but compared to
Hmm.
today's standards. But back
Yeah.
then, it was just
Hmm.
it was
Yes.
an enormous piece of equipment or pieces of
Yes.
equipment that
Hmm.
for you to do that.
Yep.
But you would then basically use Telnet or something, to
Hmm.
go in and do
Hmm.
commands on the computer from
That's right.
your very basic terminal.
Exactly. And the computers we had also were Vaxes, and they were the brand of these. I think officially, or they weren't mainframes. They were mini computers, which I think is one step down from a mainframe computer, but they were
Hmm.
similar in concept. And Digital Equipment Corporation, were the
Right.
manufacturers of these machines.
Right.
And we had, I think when I started, we had one of these when I started as an intern. Um, and then when more and more people were using the computer, and the one mainframe wasn't able to handle all the additional people, we got a second one, and then eventually
Wow.
a third one.
And so back then, do you know any of the kind of conversations that were happening around technology in a firm like SOM? Like were they checking it out, not sure? They're making huge investments, but at the
Yes.
same time, not a lot of users, right? It takes a lot of training. Did
Yes.
they see it as the future of the practice of
They did.
architecture? Mm,
Absolutely. And yeah, I don't know how much of that I knew when I started working there as an intern, but not long after that, realized that even in the 70s, they saw that this was coming. And for a company as large as we are, and the types of projects that we do, these huge and complex projects, both architecture and engineering, they said we have to invest in
mm,
some processes that would make it more efficient for us to do these things.
yeah, yeah, interesting. And was that only in the New York office? Or I assume there
Yep.
were other offices even back
Yes.
then. Yeah.
Hmm. Yeah.
Okay.
I think we had 9 offices back then, and most of um, well, we had our own computer system, right? We couldn't go and buy AutoCAD or other systems. They didn't exist. Um, and the one that we were using at Pratt, I think was like a single user type of machine, and single user sort of way of thinking about using a computer. And that wouldn't have worked for us
Mm,
because it's a
hmm.
large company and very collaborative. So we would need a system where people are able to share all the data that they're working on, that they're creating.
So were they actually developing their own software or were they
Yes,
working? Okay,
they,
interesting.
they, they developed their own. And most of that was done at our Chicago office, although
Okay.
other offices did participate in some way in the development of the tools of the software.
And that software, was it more than just the design studio? Was it also other departments as well?
Other departments as well.
Okay.
Um, at that time, the architects would sort of divide it into two types. There were design architects and technical architects. And all the architects were sort of introduced to the computer. Some of them wanted nothing to do with it, but many said, this looks interesting. I want to start using it, and engineers as well.
Yeah, that's right. Because the SOM is multidisciplinary, right?
That's right.
It's architecture and engineering, and
Yes.
that's like one of the values of SOM is even to like the structure, the engineering of the building needs to shine through the
Yes.
design of the.
That's
Yeah,
right.
yeah, very interesting.
Exactly.
So when you were originally were you drawn to SOM because of this, or was it just the firm that you chose to go work for, and then they happened to have this? How did that work out?
Yeah, it was sort of also handed to me in a way. The dean at Pratt, who knew one of the partners at SOM, the partner said, we need a couple of people to come in at night and help us to run these prints because we couldn't run them during the day. So he sent 4 people, the dean, his name was Sidney Shelov, sent 4 people to an interview at SOM, and they selected 2 of us.
Okay.
And
Wow.
I'm still there.
And you're still there. You've never worked at another firm.
That's right.
Wow. You're shaking your head. For those people who aren't watching, he's like, nope, I've been here the whole time. So what year was that?
That was in probably 84.
Okay. Wow.
So I was a student at Pratt.
Wow. So you just last year celebrated a pretty major
Yes.
anniversary there. Amazing.
That's right. I did.
Wow. So, okay, so let's talk about where that journey has taken you now throughout. Like let's hit the highlights. I mean, this has got to be so much information in here, Neil. This we might need multiple podcast episodes with you, but let's talk about where. So you're running prints at night, but then obviously
Yes.
that didn't. I mean, obviously you've done that went
Right.
somewhere very quickly.
Yep. So as I was coming in at night, and I either came in like at 5 o'clock after my classes, and started doing prints, or I would come in like in the morning before classes, like 5 or 6 o'clock in the morning. And the 2 of us used to switch off. One of us would come in the evening, the other one would come in early in the morning. And there were people there, right? It's not like,
Yeah.
people leave at 5 and come in at 9. So we got to meet a lot of the architects who were using the computers and talking with them. And I was fascinated.
So what kind of projects were they working on? Like all kinds of projects? Was it
all
were
kinds
you
of
just
projects?
okay? So it was like across the board. It didn't
That's right.
matter. They weren't saying only this project type while we do this, like figure this
Right.
out.
Nope.
It was just let's
Nope,
do
nope,
it all.
nope. And a lot of it was the people who were interested in trying this out.
Mm-hmm.
They didn't force anyone to use it, but they had enough people who were interested in using this new technology.
Interesting. So when you say printing, can you talk about like what the printing process was or the technology for printing?
Yes.
Was it pen plotters?
We had 2 kinds of plotters. We had a pen plotter, and we had an electrostatic plotter.
Okay.
And most people were using the electrostatic plotter, which was a black and white plotter, and it was pretty fast.
And was that pens or was it like a Xerox kind of a?
It was like a
technology?
Xerox.
Okay. We used to early on in school, we used a pen plotter because we would pen plot onto vellum and then we could make blueprints from that, right? I mean, that was the whole point of using vellum was to run it
Right.
through
Yes.
blue line machines and get reproductions. And so
Right.
with an electrostatic device, I mean, you're just printing new sheets all the time, right?
That's right. We were able to use different paper in those platters, and vellum was one of the types of paper. But usually we would use, much less expensive paper.
Yeah. And were those sheets or were they on rolls?
Yes, on the electrostatic plotter it was in rolls, but for the
Yeah.
pen plotter it was on sheets.
Yeah.
And the pen plotter was this huge table, and there was a vacuum, so the paper would be attached to the bed of the table. And then it had this carriage that had 4 pens, so we could use either different colors or different thicknesses of pens. And those took a long time, especially, if you had a drawing with a lot of text, a very detailed drawing, it would take hours.
Right. Yeah, I remember using the pen plotter. It wasn't a vacuum table like the one you're talking about, which I think would be what I'm picturing more of like a modern day CNC machine or a laser cutter or something, right? Where there's
Yes,
the
yes,
carriage running over the top. But
that's right.
ours actually had a roller, and you had to put sheets in it. It wasn't a roll of paper, but the pen only went back and forth, but the sheet went
Right.
front and
Yes.
back, right? And
Yes.
so you would just have this symphony of
Yes.
movement that
Yes.
was
Yes. Yes.
so mesmerizing to watch that
Yes.
happen. And then it would pause and pop that pen weight out and stick a different one in if you needed thicker lines, and then it would go at it again. And it was so interesting to watch it because it would draw a line over here, but then it would jump all the way to the other side of the page and draw another line. So the movement just seemed extra exaggerated. And then you start to think about efficiency of, okay, well, what if we start to draw them in the order so that the computer prints them in that order? It's like all of these things just kind of waterfall into
That's right. Yes. Yes.
the next evolution of how we do it.
So shortly after I started working at SOM full-time, after I graduated, in addition to these platters, they also got a laser cutter. And I think SOM was the first architecture firm to use a machine like this in our model shop. So we'd use it to create models. And, same thing. It would, like this pen platter that you're describing, cut the material in the order that it was drawn in the file. It would jump all over the place. And that made a lot of noise. That was like a symphony.
Right. I mean, I used a laser cutter very early in school as well. I think maybe I was in my second or probably third year. And my structural teacher, who was also my design studio teacher at that time, I did Grimshaw's Waterloo Station. We did a section model through that, which is a three-dimensional truss, really beautiful design. And I did a section, and he was blown away by the output of that model. And I had to learn so much to get my microstation drawing output as a laser cut, because you couldn't run the laser cutter out of microstation. There was I think it actually ran through Corel Draw back in those days. And when you would export a DXF out of microstation into Corel Draw, the circles never came out right. And so you had to redraw a lot of it in Corel, and then you had different colors for different depths if you wanted to score versus cut in the laser, things like that. And so the reason I'm explaining this is because we had to go through so much learning and testing just to translate from the one medium to this new machine and output type. It was quite a learning curve, and there was no one around to teach us how to do it. It was just like trial by fire, learn by doing.
Right. Yep. So when I was at SOM, I joined the computer department, right? The platter operators were part of this group of about maybe a dozen people in New York, and I don't know, maybe 50 people firm-wide. And some people were writing the software, writing the tools that we were using. Some people were teaching people how to use it, right? We were doing all kinds of things. So when we got this laser cutter, and we were using our own system, so there was no direct interface from the files that we were generating. So there were some people in the New York office in the computer department who were excellent at writing code. So they wrote some software to be able to take, our files and make laser-ready files.
Nice. How did the model makers feel about that? Did they see it as a tool to augment what they were doing? Did they see it as a threat? A little bit of both?
No, there were two people in the model shop, and I loved models through college, and also enjoyed when I could being in the model shop, either using the laser cutter or doing anything in the model shop. I really loved that. They were excited, and they were helping the people that were writing the tools to translate, to make it easier for them.
Yeah.
And they thought it's going to save so much time, and it actually didn't.
Right.
And the reason it didn't, we made our models so much more detailed that it took.
Sounds like almost every technology in architecture.
Exactly.
we can do more now. It's not we can take it easy and
exactly.
we can do more. We can add more detail. We can
Yes.
like the design's never done.
That's right.
So So I'm also curious how visualization, like rendering, was starting
Hmm.
to work its way in those
Hmm.
early days because you're
Yep.
working in 3D. I
Yes.
mean, then you're taking 2D projections and maybe outputting those to the laser cutter so
Yes.
that physical models could be built. But
Hmm.
we also had watercolor renderers, real
Yes.
people who used to
Yes.
do that in firms,
Hmm.
and then three-dimensional visualization and rendering started to work its way into the
Hmm.
scene. And I'm
Hmm.
curious how that
Yes.
was a parallel track with this physical
Yep.
output.
So the software that we had created ourselves was sort of in modules. So there was one module called Draft, which is a bad name because it was not just drafting, creating 2D drawings. It was a 3D modeler. And there was another module called Plot that let you take um, some projection of your model and print it on paper. We had another module called Render, and
Hmm.
that would take the 3D model and run it through some ray tracing processes and create an image.
And
Uh,
did the renderists, the people who were doing because we all had the architects rarely did their own renderings once they get out of school because you're so busy working on projects.
mm,
Somebody was dedicated to that. Like you had two people in the model shop who were dedicated to
yes.
making models.
Mhm.
Were they using those as underlays for their perspective imagery, or how did that process
Well,
work?
so this render software was able to create renderings directly, but they were
Okay.
primitive. They were,
Hmm.
it was able to do reflections and amazing things, but the output looked very primitive. I mean, the
Hmm.
resolution was low. They took days to create one image, but it was the architects that were doing it.
Okay.
Right? And even the architects, our model shop had some full-time people who were running the shop, but even architects would be using the model shop and running
Nice.
the laser themselves. Um, we also hired renderers. I remember we had this watercolor renderer who would come into the office maybe a couple of days a month, and we gave him a desk, and he would do watercolor renderings, which was so beautiful. And often, or eventually, and then often, they would ask me to create a wireframe projection of a building that he would use as an underlay.
Hmm. Hmm.
So it'd make it
Just to get
easier
the
for him.
perspective done
Exactly.
quickly. Yeah,
Exactly. That's right.
quickly.
Yep.
Right. Wow. So it's incredible that you guys were actually developing your own modular
It,
system
it
for all
is.
of these
Yes.
different parts.
Yep.
Absolutely
Yep. And
incredible.
then the engineers had their own modules for analysis and design, engineering design, and different kinds of engineers. We had one for structures and electrical and plumbing.
It's a huge investment for the
Yes,
company to be making. And you said there were about 9 offices at the time. And was that pretty
that's right.
evenly distributed throughout the firm or just in the major cities, or how did that work?
The major cities primarily,
Okay. Wow.
because especially to buy a mainframe,
Yeah.
you want a lot of people to be using it. You don't want
Right.
to get one for one or two people.
Where did it go from there?
So when I graduated and started to work at SOM full time, I no longer had to come in at night and plot
Uh-huh.
drawings. But one of my first, well, two things, two of my first tasks. One of them was to teach people how to use the software that we had developed. One disadvantage is, we're the only ones using the software. Um, so anyone who wants to use it coming into the office, or even if they're already here, we had to teach it to them.
Mm-hmm.
So we had a 2-week training course.
Mm-hmm.
And because as I was coming in at night and talking to the architects, I was also learning how to use it. So by the time I graduated and started full time, I was able to teach it to people.
Okay. And
Um,
so was that an extension of you being in that technology kind of department
yes,
was also
yes,
doing the training? Okay.
that's right, that's right. And then I was also assigned to projects. So even though I was in the computer department, I would be working on projects that were using the computer, and either just helping them out because they needed more people to
Mm-hmm.
to create the models and the drawings, or to help the people who were using it on the project to use it in a better way, right? Sort of teaching them as they're working on the project.
Yeah. What was 3D used for? I mean, was it strictly used for these kind of projections, or would you call this kind of an early version of BIM in any way? I'm just curious how that.
Yes. Well, two things. We were using it as a design tool, not just to create
Mm,
documentation of the project, but using it,
mm,
to see things in 3D and spin around them and use it to help us design the project. Um, they were using it to visualize design and as a design tool,
mm-hmm.
also to create 3D documentation.
Oh,
So
okay.
we would often create, even in
So
addition to what,
axon, kind of like
yeah, exactly.
axonometric,
That's right.
going back
Yep.
to your early
Yes.
days of,
Yes. Hmm.
right? Okay.
Yep. Axons, even elevations, right?
Mm-hmm.
Elevations with shadows and,
Oh, okay.
you know,
That was pretty unconventional,
perspectives.
I bet, back
Yes.
then, right?
Hmm.
I mean,
Yes.
and to be able to communicate depth on facades and things
Yes.
like that, I bet.
Hmm.
I mean, that it's just when you see it, it's obvious, but we
Absolutely.
weren't
Absolutely.
taught. We
That's
weren't
right.
taught to do it
That's right.
that way, right? That
Exactly.
was an innovation inside the
Yes.
firm.
Hmm. Yes.
Yeah, very cool. All right, so I'm curious how this makes the translation to where programs like AutoCAD and MicroStation started to come onto the market and
Yep.
become more democratized and more available. And then
Hmm.
PCs landed on people's desks and away from the mainframes. I mean, there's a lot of ground that has been
Yes.
we've
Yep.
experienced being covered in the
Yep.
last 20 years, 30 years.
At some point, as we were developing our own system and using it ourselves, right, we weren't selling it or anything, but IBM came to us with a proposal, and they said, "We'd like to work together, and we see what you're doing. We'd like to take it and market it."
Mm,
So we worked together with them to. It was the same system. We renamed it AES, Architecture and Engineering Series, and IBM was sort of selling it to other people. It didn't sell very well,
mm,
either because people by that time were starting to look at other tools that were also becoming available, or IBM wasn't as good at marketing software as they were in marketing hardware.
mm-hmm, mm-hmm,
And then we ourselves had to decide, should we continue to maintain our own tools and teach people how to use them, or should we start to use tools that were becoming more and more available? Um, so we put together a committee, and in the end, we were actually choosing between our own tool, or what became AES, AutoCAD, and MicroStation. Those were the
mm-hmm,
three things we were
mm-hmm.
looking at, and we chose AutoCAD.
Okay.
And a couple of the issues, one of them, it's a huge job to maintain your own software.
Mm-hmm,
And they thought at that point, it wasn't worth the effort. Also, people coming into the office, enough people were coming in knowing AutoCAD that
mm,
training would either disappear or be much less than a two week program. And we were also starting to share our models or drawings with consultants and others. And when we were using our own software, we had to create translation programs.
yep.
And those also needed to be maintained as our own software was developing, and also the target software was developing.
Mm-hmm.
So if we were using AutoCAD, we figured we would have much less of that to do.
Let's take a short break from the conversation to invite you to join the most influential technology leaders in the AEC industry at Confluence. Composed of in-person events and a podcast co-hosted by yours truly, Confluence is designed to foster conversations between AEC firms and technology companies so they can learn, share, and engage with each other to support industry innovation. Software company Avail, which creates content management solutions for the AEC industry, started hosting Confluence events in 2019 to understand what firms are needing, wanting, and thinking around technology. To learn more about Confluence, explore upcoming events, and listen to podcast episodes, go to confluence.getavail.com. My thanks to Confluence for supporting this episode of the Troxel Podcast. And now, let's get back to the conversation. Yeah, that was interesting. You just reminded me of the firm I was with, we used MicroStation, and so there was a lot of time spent just converting DGN files to DWG files and back and forth. And that wasn't done in the host application. It wasn't like file export as a MicroStation. No, that was not going to be a thing. We had to have special translation software just for that.
Mm-hmm.
And your engineer might be using the other platform, right? And so
that's right. That's right.
Yeah, that was happening a lot back then.
Yep.
And it's interesting that you say that the people were coming in knowing it, and obviously there's pros and cons to that too, right?
Yes,
they may not be using it the way that you use it, but they have the fundamentals. They understand how commands work, and so overall, I would say is probably a net positive. But
that's right.
You still have to get rid of people's bad habits.
Yes, exactly. That's right. And AutoCAD initially was designed as a single user working on one drawing at a time, and we didn't work that way, and we didn't want to start working that way, because we were still doing large, complex projects. So we wrote a sort of shell to use on top of AutoCAD. So if you're using AutoCAD, you would actually have to go through the shell, and it would ask you, like there would be an interface with the form, what floor are you working on? What aspect of the floor? And it would actually look at many files and sort of load up what you needed to work on what you needed to do.
Wow.
And then when you're all done, it would know exactly where to save everything to.
Very cool. Yeah, when did XREFs actually get put into AutoCAD? It was quite a while after that, right. I assume.
This was before XREFs. We were using AutoCAD Map, I think it was called.
Okay.
That had some features that allowed us to do that.
Wow. Very cool. And so obviously you were still developing certain aspects of the pipeline so that you could work the way that you were working.
That's right.
And but for the most part, you stopped developing your own full-fledged products to work together. You were relying on off-the-shelf software at that point.
That's right. And I was reluctant to give it up. I got so comfortable using it and enjoyed using it. I think I was the last person to use it.
Oh, really?
Yes.
Well, I assume that, like I said, desktop PCs had to be coming in at some point where you didn't need these terminals and the mainframe, and at some point the mainframe's very outdated, right? It's not going to move even as quickly as the desktop machines.
That's right. So we did that in two steps, actually. When IBM joined in the development of this tool, we sort of went away from mainframes and started using heavy-duty workstations. They were Unix workstations. So one person would get one workstation, and they were so expensive. And more and more people were using it, so that was a bit of an issue. And then as PCs were becoming more available, IBM finally ported the software to the PC environment. So in the end, we were able to use it on PCs.
Oh, that's cool. Wow. And so how did that roll out across the firm start to, like, how fast did that happen? Because like you said, even what used to be a terminal and mainframe then became a very expensive Unix workstation.
That's right.
I mean, even back then it was in the tens of thousands of dollars, right? For that.
Yes.
For that. It wasn't just a few $1,000, cheap PC clone, because remember there was IBM and then there were all the clones back at some point. At some point, that was a thing, because people were very interested in not spending money on the real IBM workstations. But yeah, how fast did that roll out? That evolution happen in the firm?
It probably took a couple of years at least,
because
there was a lot of overlap. Some people were still using AES, and people were starting to use this sort of version of AutoCAD that we had developed.
Yeah. Wow. Can you talk about the kinds of projects that you were doing back then? You said you were getting really complex, big projects. I mean, talk about maybe some of SOM's. Like, you've seen a lot of projects happen over the time. Can you talk about the kinds of things you were seeing?
Yep. So lots of, large commercial buildings, skyscrapers, lots of large projects, but sometimes not tall. We were doing a lot of airports, for example. So it's a huge project, but sort of flat. Just very spread out. I remember one of the first projects that I worked on after I started full-time, when I was assigned to help out with a project, was a hospital that we were doing in New York. And I was creating the drawings for the hospital. My assignment was to work on the reflected ceiling plans.
Oh, yeah.
And this was when we were still using our own software before AutoCAD. And, just drawing grids and rooms. And I said, there must be a way to do this. And our tool had a very simple, I don't even know if I would call it a programming language, like almost like a simple scripting language, right? That used the commands that were part of the tool, like draw a line or, draw a polygon. But it was able to do things like loops and sort of tests and, basic logic types of things. So I wrote a little script. We called them command files to draw a reflected ceiling plan. You would pick the room outline and you would say, do you want the lines to be in the center or do you want a tile in the center? And, either assume 2 feet by 2 feet or it would ask you that question as well. And it would just, in a second, create the reflected ceiling plan. And, pretty much in a short amount of time, other people were starting to use it.
I bet.
Yes.
And
then there were lots of that. Yes.
You automate that low-hanging fruit of the super repetitive stuff like that. It's like, oh yeah, I want people. That's crack
right.
for them.
Yes.
Yeah.
Exactly. That's
Okay.
right. Yep. And I really enjoy doing those kinds of things. So I eventually got to do a lot of those types of automation tools.
And nobody was asking you for that, right? Like it was just draw
that's
the
right.
ceiling plans.
That's
Yeah.
right. Exactly. That's right.
And so you said like other people who were users were interested in saving time and not
Yes.
drawing those. But
That's
how,
right.
how did leadership respond to that? Did they see that as a...
Yes, absolutely. So we
It's
were developing
interesting.
a collection of tools, and they became part of this collection.
So you had like a toolbox full
Yes.
of these different kinds of tools. I mean,
That's
I've heard stories of people who they would do things like this, like automate parking stall layouts,
Yes.
and ultimately would get fired for it because it was like their leadership did not know what to do with if we're not going to draw all this by hand, right?
Right.
It's
Yes.
interesting the different kind of
Yes.
openness to
Absolutely.
the way technology was changing the practice.
Yep. Mm-hmm. Yep.
Were
And I
there
was
any
also
projects?
go ahead.
Go ahead. Go ahead.
So in addition to doing these mundane tasks like working on reflected ceiling plans, if there was a project that had some piece of complex geometry, I would often get asked to help with that as well. Some sculpture or a paving pattern that was not just rectangles. So I would often create tools like these command files, but not something that many people could use, but a tool that would be, for one specific purpose, one specific model.
Those were early days, Neil. Like you're talking about, it's just
Yes.
incredible because now that's Grasshopper or Dynamo or whatever.
exactly.
And
That's right.
yeah, but you were doing that back then. I mean, that's really cool. Were there, and I assume that kind of came out of your morphology
Exactly.
kind of
Yes.
roots, right? It was like complex geometry. That's Neil. He's the
Absolutely.
That's really cool. Wow. Was there any project that was really, I guess the answer, it could be challenging, transformative. I don't know. Like, was there a project that you look back on? It was like that was something that really changed the direction that we were going.
Yeah, there's one project in particular that wasn't as early as that, but a little bit later, we were using AutoCAD, and we were designing a school in Massachusetts. Deerfield Academy is the name of the school. We were doing a building, and we were collaborating. Some of the education projects we collaborated with artists, for example, and we were working with James Turrell on this particular project. And one aspect of the design was a skylight, and we wanted the light to come through the skylight, but not sort of light up the space, but project a spot of light on a wall that was near the skylight.
Mm-hmm.
And they asked me to work on it because the geometry turned out to be pretty complex. Initially we wanted, and the spot of light would move as the sun was moving.
Sure.
And, the intention was to have the spot of light appear all day long and all year long. At different times of the year, the spot would move up and down the wall, depending on whether the sun was low or high. And during the day, it would move sort of from left to right. And what you saw in the ceiling, right, if you walked into the space, was a hole that was about 6 inches in diameter that the sun would come through. But the space between the ceiling and the roof was about 3 feet. And the opening on the roof needed to be much larger.
Yeah.
And in order for this effect to happen all day, the roof would, the hole in the roof would be huge. It would take up the entire roof. So we said, let's limit it to some period of time that would be reasonable, right?
Mm-hmm.
That would still give the students, for example, an idea of the movement of the sun, right? Since this was a school building, we wanted to use this as a teaching tool. And we said 2 hours would be an effective time. So from 11 o'clock in the morning till 1 o'clock in the afternoon, you would see the spot. And it would also create a reasonable size opening in the rooftop. So my task was to figure out what would be the shape of the opening that would limit the sun to within this 2 hour period of time exactly. And the interesting thing there was it's a beautiful design, but it wasn't that a human designed it. It was designed for a particular behavior. And that's something that interested me and does in so many of the projects that I work on. That was a specific case, designing something to allow the sun in at particular times, but now the behavior could have to do with energy or other sustainability aspects or different big structures.
So that really opened up kind of the possibilities of how technology could be applied.
Yes.
To figure out these kinds of design challenges.
That's right. And it's not just technology, I found out. It's really changing people's way of thinking about design without saying, here's my form, I want to create this form, but rather, here's the behavior that I want. Yeah,
it's like looking at it in reverse. A lot of times you're using the tool to kind of break down or deconstruct or make something buildable or whatever, but you're actually talking about it like the other way around. It's like, well, here's the outcome we want to accomplish.
Yes.
How do we design it to
That's
achieve that, right?
That's exactly right. Yeah.
Yeah. Wow. That's a really cool story. I I like that a lot. So did that start to open up more possibilities when it came to design at SOM because of the way you guys went about taking on that challenge?
Well, it was easy to convince people that they should be using this new tool, the computer, to make it easier to do the work that they do. I think it was a harder challenge, and it still is, to change the way that people design or think about designing.
Yeah, those grooves are deep, right?
Yes, absolutely.
Very deep.
Yes. And it's you think people think that I'm giving up control because I want to have ultimate control over the form, what this looks like, but you're controlling in a different way.
Yeah, right.
And you're going to get a form that you couldn't possibly have thought of without using this process and these tools.
Yeah. Well, I'm curious about, it sounds like you've been doing 3D for quite a long time, but do you feel like there was a shift where it went from primarily 2D with a little bit of 3D to primarily 3D with 2D outputs based on that?
For many people in the office, I think so. But from the start, I was always modeling in 3D.
Okay. Interesting. So
maybe except for those reflected ceiling plans.
Right. Those macros, those little computer files, those programs where they needed 2D. Yeah.
That's right.
So can you talk about that shift though, how that started to happen? Because I know you're really known as kind of maybe the earliest adopter of BIM, at least for a major project. And so I'm curious how that got to the point where that was even a possibility for you.
My definitions of terms like computational design and BIM, I think are much broader than most people's.
Okay.
So when I think of computational design, and that's what I do, I'm a computational designer, and I use computer tools to do that. But I think of computational design as something that doesn't really require computers. And my favorite computational designer is Gaudi.
Mm.
And it's
Mm-hmm.
because of the way that he thought.
Mm-hmm.
It's his process, which was a very
Mm-hmm.
computational design process, using logic, using geometry, um,
Gravity,
gravity.
physics.
Exactly, that's right. Yep, yep. Influences from all the sciences, nature as well.
Mm-hmm.
And BIM as well. I have a broad definition of BIM. And I think some of the early tools that we were using, I mean, BIM wasn't a term that we used back then,
Mm-hmm.
but applying information to the models that we were building, to the
Mm-hmm.
elements within the models, is something that we've always been doing. Whether it's because of the layer that it was on, so it knew
Mm-hmm.
it was a wall because it was in the walls layer, or attaching additional attributes. And AutoCAD lets you do that. And the tool that we were using also let you assign metadata or non-graphic information
Mm-hmm.
to the objects in the model. So we were able to make queries based on that information.
What kinds of examples of that metadata can you remember that you were putting on that? So was it like ratings for a wall? Like, so if you have all the interior
Yes.
walls on an interior wall layer, it's
Yes.
still not differentiating elements or, even geometric kind of relationships, but is that the kind of thing you're talking about?
Yes, exactly.
Yeah.
Or
Okay.
doors, we had we call them symbols, right, instead of
Mm-hmm.
blocks, and we were able to attach information to those elements like manufacturer, like rating.
Mm-hmm. Right. Yeah, I remember early days of MicroStation. Our firm had written libraries for their cell libraries, is what they called. So they weren't blocks and they weren't symbols.
Mhm.
We MicroStation had to have its own word, and it was cells. And
Mhm.
so cell libraries and so it was doors, it was windows, it was toilet, it was bathroom fixtures, sinks, all the things it used over and over and over again in a project.
Mhm.
And those were a gold mine. I mean, to not
Yes.
have to redraw that stuff over and over again, and
Yes.
it automatically went on. In MicroStation, it was levels, it wasn't layers.
Yes.
They have their
Fabrics.
proprietary naming. We
Yes.
had 50 levels that we could put things on, and level 15 was walls, for example, right? But it was
Mhm.
like it automatically went on the right level. It automatically was the right color. It had the metadata already attached to it. And
Yes.
these were the early kind of efficiencies in CAD.
That's right.
Yeah.
You mentioned cells, and our initial software that we developed. When I started, I think we had 5 different types of elements. So we had lines and polylines and text and
Mm-hmm.
symbols, and uh, there was one more. I forgot what it was. We didn't have circles or arcs.
Mm-hmm.
There was a command to add a circle, but it would add it as a segmented
Mm-hmm.
shape.
Mm-hmm.
And you could define how many segments you want. And
Mm-hmm.
they kept improving the tool. So at some point we had arcs and circles that were real.
Yeah.
Um, we had walls eventually. So when you
Mm-hmm.
added a wall, you could define what the wall looked like. It's not a single line, it's a double line, or,
Mm-hmm.
has these other elements within it. They developed one element type that was called a cell.
Mm-hmm.
And I mentioned we had these command files or these scripts. A cell was a script that you can place in the drawing. So it had a location. And the instructions in the cell can be, read my location, tell me what room I'm inside of, tell me the area of that room, and then add a piece of text with that area.
Mm-hmm. Very cool. Yeah. So it was like a smart block at
Yeah,
that point,
exactly.
right?
Yes.
It was
Mhm.
reading the metadata around it based
Yeah,
on some set of rules. Yeah.
that's exactly.
Very cool.
Yeah.
That
Unfortunately,
that
that
just
came pretty late in
mind
the
blowing.
development. Yes, it really was.
Yeah. You
Yeah,
just place this in there and it knows
that's right.
things around it. Yeah. Very
Yeah,
cool.
yeah, yeah. It came pretty late in the development process, so most people didn't use it or even know about it.
Yeah.
But a
Yeah.
lot of times, now I'm doing a lot of scripting in Grasshopper
Mm-hmm.
for teams that are using Rhino, and often I'll use containment as a way to find out, what things are contained in other things.
Yeah. Very cool. The information lives on even today,
Yes,
right? I mean,
yes.
it's really interesting. Let's talk about that early BIM project. Can you kind of introduce how that happened, and the one I'm talking about, the
Yes.
big one.
Yep. So as we were using AutoCAD, right, and working with Autodesk, right, we knew very well the people at Autodesk that were developing tools for architects, and one of them was Revit. And we started using it, actually, even before Autodesk acquired
Okay.
Revit.
So you were using the Charles River software
Exactly.
version of Revit.
Yeah. And, I wouldn't even say using it. We were looking at it and
Okay,
testing it out.
Mm-hmm.
And then when Autodesk acquired them, I think we became even more interested because we knew that they would put a lot of development resources into making it a useful tool for architects.
Okay.
And initially we had the same concern that we did about AutoCAD, that it wouldn't be appropriate for large teams working collaboratively on large complex projects. But they said that they would work with us to make it work for the most complex large project we can imagine, which was the World Trade Center.
Okay.
And we started using it and ran into issues. They actually had a team of people that would spend time with us in the office to do two things. They would show us how to overcome some of the obstacles that we were running into, but they were also learning about how we were using their tool. And they would say, okay, architects want to do things this way, and they would change the software to make that possible.
And was that a pretty fluid process at that point? I mean, I think nowadays, and how complex the software is, and that's got to be extremely difficult to operate like that. But maybe back then it was a little bit easier.
I think so. I wouldn't say it was easy.
Right. Easier than today, though. Yeah.
Exactly. Yes.
Oh, that's really interesting. So how was the decision made then? How did you get comfortable enough? Was it because they were in your office before this project was a possibility in doing this and working with you, or did that come afterward? How did that play out?
Yeah, I think if they weren't in the office and especially watching how we were using this tool, I don't think it would be the same tool today. I think it's much better and usable for these types of projects than it would have otherwise been.
And so are we talking, what year is this at this point?
This was early 2000s.
Yeah, I was going to say 2002, 2003.
Exactly.
It's like right around when the acquisition happened. Obviously, it's after 9/11, but
that's right.
But still, I mean, there was a big design competition for that whole site, and wasn't it Libeskind?
Yes. So there was a competition for the master plan.
Right.
And Libeskind won that competition. I think there were 5 finalists, and Libeskind was the one that was selected. And I think he thought that he would also be designing all the buildings on the site. But I think Larry Silverstein had other ideas. So David Childs, who did a lot of work with Larry Silverstein, was asked to design Tower 1.
Nice.
At some point, it was called the Freedom Tower.
Hey, everyone. Let's take a quick break from the conversation to pay some bills around here. This episode of Troxel is brought to you by Troxel Plus members. That's right, my incredible paid supporter members are making this episode possible. Their direct support ensures that I can continue exploring the intersection of architecture, technology, and the future of design with the leading voices in our industry directly to you. So let's talk about why you might consider financially supporting the podcast too. By becoming a Troxel Plus supporter, you're not just helping sustain these conversations, you're also gaining exclusive benefits like ad-free episodes of the show and my Leadership Edge email newsletter, where I analyze episodes and deliver the insights and key takeaways right into your inbox. Your small contribution makes a huge impact. And if you've been enjoying Troxel and want to be part of the community that keeps it thriving, please consider joining today. Head on over to trxl.co and click the subscribe button either in the upper right-hand corner or at the bottom of the page, or you can visit a link that I've put into the show notes. Once again, my sincerest thanks to the Troxel Plus members who have made this episode of the podcast possible, even though they aren't even hearing this ad because theirs are ad-free. Now, let's get back to the conversation. That's right, right. Yep. I mean, I remember that name, and I also remember the renderings from the Liebeskin, and I remember
Hmm.
very early it was like that's never going to happen. Like
Hmm.
it was an incredible master plan, but it was
Yes.
also like there was so many asterisks on it where it was like
Yes.
that's not what's actually going to get built, and kind of everybody knew it, but there was still this competition and this winner
Yes.
declared. I
Hmm.
thought that was such an interesting
Yes. Yes.
period
Yes.
in
Yes.
American architectural history.
Hmm.
Yeah. Okay, so Autodesk is in your office. They're listening to you. They're helping develop the software based on how you work, and they're also
Hmm.
teaching you maybe
That's right.
ways to approach because it's going to be
Yes.
different than
That's right.
what you've done before.
That's
And
right.
so when you guys were officially going to do Tower One, like, was it a tough decision to say we're going to do this in this tool, or was it like let's see how this goes? We can always declare bankruptcy and export to 2D or whatever, or was it like no, we're doing this no matter what? I'm curious what the thinking was.
Well, I think the leadership had a big say in that.
Mm-hmm.
So Carl Galeotto, who I mentioned before, he was the friend of the dean at Pratt that actually got me as an interview as an intern. He had an incredible vision, and he said we have to move forward with the tools that we use. He was a partner in charge of technical um,
Okay.
architecture at SOM, and he said we're going to make this happen. And not only, I was going to say, not only did he force people to do this, but just his way of leading, encouraged people also to be really willing to learn this
Mm.
and to make this work.
So that's a key part of the
Yes.
success story, right? Is that leadership that was there early on
Hmm.
in this project? Yeah. Yeah.
Yes,
Very cool.
that's right. And, this was still probably one of the more complex projects. And we've been using it for many projects since then.
Of course. Yeah. Wow. So can you kind of talk about the challenge? I'm sure it was challenging still to use. I mean, think about how young Revit was at the time and obvious limitations, and it's been through a lot of development since then. But what was that experience like using a completely different style of tool, or was it that different? Was it kind of the way that you guys had been working and you just applied it with that tool, or how would you explain that?
Um, so as we were starting to use Revit, it was mostly the technical architects that were sort of using it
Mm,
because uh, it was really less useful for design exploration.
mm-hmm.
So to be really free in creating models, either as if you were sculpting them in clay, right, designing a form that you have in mind, or even, as I was mentioning before, have a behavior in mind and using a tool to sort of
Mm-hmm.
show you the model that would reflect this behavior. Once you had a form, I think it was getting really good at documenting it, but to
Mm-hmm.
generate the initial form, um, not as much.
Right.
So we were looking at other tools to do that, and eventually started using Rhino as sort of the standard SOM tool for the design people.
I was going to ask that next. Just like when did that track show, or when did that app show up in the
Mhm.
toolbox?
Yeah.
Because, I mean, yeah, if you think about the geometry of that tower,
Mhm.
it's actually a pretty simple. I mean,
Yes.
a lot of big move architecture is just
Mhm.
one big move, right? And like this
Yes.
loft, this blend from one shape to another.
Mhm.
But like you said, like the early Revit tools didn't have very
That's
many
right.
options for lofting or
Mhm.
massing. I mean, I don't remember. I didn't use it that early, but even in
Mhm.
2009, it was still pretty basic when I
Mhm.
started using it. So I was a
Yes.
later comer
Mhm.
to the Revit game.
Yep. And the World Trade Center building that was built, which is simple in form, as you said, is not the first version of the project.
Mm.
We had actually
Hmm.
designed a version that was more geometrically complex. It actually
Right,
had two
that's right.
facades that were twisting, um,
Hmm.
and we had to change it for several reasons, and it became became the simpler one that
Oh,
you see now. But even that earlier one, we were still using Revit to do the documentation.
how far did you guys get along in that process before the design changed?
Yeah, we got pretty far along in CDs.
Yeah.
It was
Oh,
pretty. pretty far.
Painful.
Yeah.
Maybe. I don't know.
Yep. Yeah, it was.
Yeah. So, I mean, overall, I mean, the building's there. It's a success. It's wonderful. I mean, do you feel like it was transformative for SOM to have done that project that early in Revit? Did it really set kind of the standard moving forward from that point on, or was it still like, we'll really pick and choose which projects we use this on?
No,
How'd
I
that
think
play
it did
out?
become the standard, and
Mm,
some of it was because of, the leadership,
mm-hmm,
making sure that it was, because yeah, I think the investment in using it was pretty steep. So wanted
yeah.
to make sure that we were actually using it.
I
But
would
using it,
assume,
mhm,
I was going to say, I assume for Rhino as well, right? Like
yes,
you said, it
yes,
became kind of the standard design tool,
that's
and
right.
yeah,
Yeah. But that tool, Rhino, I think many more people enjoyed using Rhino for what they were
mm,
using it for
sure.
than than people using Revit.
Hmm. And you said your technical department was really doing most, I would assume, the modeling
Yes.
of the tower, but the design side is happening
Mm,
so talk about kind of like, the buzzword of the mid 2000 or early 2000s was interoperability, right?
yes.
Like
Hmm. Hmm.
everybody wanted to figure out how to send stuff from, back and forth,
Yeah,
at least one direction, if not back and forth. But
that's right.
SOM had some tools in its toolbox that made, at least the understanding of how to make that happen. Did you write a lot of your own tools to do
We
that
did
kind of
write a
thing?
lot of our own tools, yes.
Mm,
But then also looking at tools that were available to
mm-hmm.
sort of, because we had to keep updating our own tools. But if something was available, we I think would prefer to use that. Although there's a
Yeah.
trade-off. If you're writing your own tool, you really have control over exactly how it works and what it does.
Mm-hmm.
If you buy
Yeah.
something,
The build versus buy question is
yeah,
something that, yeah,
that's right.
that's a hard one.
Yes. Yep. And, because I was brought up on our own custom build tool, I always lean towards the build side.
Yeah.
And sometimes that frustrates some people. I say,
Right.
we want to do something, let's actually do it and create a
Yeah.
tool for it. But they'll say, "Oh, I found this plugin that does it."
So when did Grasshopper come on the scene for you? Was it around that same time as well, or was it after that?
Yeah. It was the late 2000s,
Okay.
like 2005 to 2007, I would guess.
Okay.
Because ever since those early days when I was writing these command files to do reflected scaling plans and then so much more, uh, when we switched to AutoCAD, I couldn't think about not working that way.
Mm,
So I learned how to use Lisp in
mm-hmm.
AutoCAD, and
Mm-hmm.
yeah, made it do everything for me.
Yeah.
In 3D, right? I would anything I had to do, I would usually use Lisp to do it. And people were amazed because most people were using AutoCAD as a 2D drafting tool.
Mm-hmm.
And then even to imagine that you could work in 3D in AutoCAD was surprising to many people.
Yeah.
But then to see with a tool like Lisp, how much you can do is, I think even, and I've, been doing it, is pretty amazing.
Yeah. I remember the 3D face command in AutoCAD
Yes.
back in the day. But
Yes.
even the early version of Rhino, like the earliest version, it was running on top of AutoCAD, right?
Yeah.
It was like a
Yep.
NURBS
Hmm.
model. It was
Yep.
a command set of running on top of AutoCAD
That's
stuff,
right. Yep. Yep.
right?
And Rhino was easy to learn because if you know AutoCAD, the commands are pretty much the same, except it
Right.
has these additional features. Yes.
And at some point they added Rhino script into Rhino. I
Mm.
don't know when that happened. I don't have the exact history, but it didn't start with the earliest stuff. It
I
came
don't think
later.
so. And I never used Rhino script.
Hmm.
I was
So you
still
went
using,
straight to Grasshopper at some
yes,
point.
that's
Yeah.
right.
Okay.
Hmm. Yep. And, even learning AutoCAD, a funny story, um, we, at some point, someone who was at Pratt, I think he was one of the directors in the School of Architecture, went to a different school, the New York School of Interior Design, and we were still using our own, software. He called me up one day and he said, "Neil, at this new school that I'm at, um, we're starting to teach, you know, computers to the students, and we want you to come and teach AutoCAD." And I said no. I said, I never thought of myself as a teacher,
Mhm.
right? It was never something I was interested or thought I could do very well. And I didn't know AutoCAD because we hadn't
Yeah.
started using it yet. And I don't know how, but he convinced me that I should do this.
You don't need to know how to use it. You just have to be one step ahead of the students.
Exactly.
Yeah.
And that was one of the best things I ever did.
Because it forced you to learn it?
It forced me to learn it, and in a different way, I think, than if I had started using it on a project.
Oh,
I had to learn
interesting.
it in order to teach it to other people. And
Yeah.
then once we started using it here at the office, I sort of had a huge head start
Yeah.
and was able to teach other people how to use it as well.
I mean, AutoCAD and even Rhino are apps that were built for not specific to architecture, right?
That's right.
And so
That's right.
you're using them and applying them to architecture and maybe building some tools on top that make it more
Yes,
architectural, right?
that's right. Mhm.
Um, same thing with Grasshopper, right? Grasshopper being
Yes.
a plugin at the
Hmm.
beginning for Rhino. I mean, it didn't come
Yes,
with Grasshopper back in the
that's
early
right.
days, and it was still kind of a general visual programming language that you could use for geometry, right? It wasn't
That's right. Yes.
specific to
Yes.
architecture. A lot of architects
Hmm.
have like it for some reason. I'm not quite sure why, but maybe just because it was so extensible, really took off in the
Hmm.
architectural
Yes.
profession.
Hmm.
Did you were you aware of others in the profession using these tools when SOM was adopting them, or did you feel like you were the early examples of people who were adopting these because you saw the potential?
Yeah, I was definitely one of the early adopters.
Hmm.
And, in 2006, so I think we were using Rhino, but this was before I had started using Grasshopper. In fact, I'm not sure exactly when Grasshopper came out. It might be,
Mm.
this might be before that. Uh, I found this conference called Smart Geometry,
Hmm.
and I thought it would be interesting to, just check it out. Just the name, I think, sounded so interesting that I wanted to see what it was all about. And I either convinced people to let me attend this conference, or I just went on my own. I don't remember. I might have gone on my own. Um, and the conference was, I think, sponsored by Bentley. And the tool that they were using at the conference was MicroStation and generative components.
Hmm.
And generative components is a visual scripting language, and
Hmm.
it's, I think, seen as the predecessor to Grasshopper. So before this conference, which was in Cambridge, England, we had to take a workshop, a 1 or 2 day workshop, to learn generative components. And I was fascinated.
I bet. Yeah.
Um, and then when I got to the conference, I met so many other people there who were doing similar things and facing similar challenges in other firms. People at
Mostly
Foster's and
architecture?
Grimshaw.
Was it all
Yeah,
architecture? Yeah, okay.
this
Yeah.
was primarily geared towards architects, yes.
Okay.
So
Yeah.
that also was a changing, life-changing
Mm,
event for me.
nice. Yeah, the earliest example I can remember from that kind of thing was I was a Mac user, always
Hmm.
a Mac user. So they did have AutoCAD pretty early on the Macintosh, and then at some
Hmm.
point it went away. A MicroStation was available on the Macintosh, but the generative side of things for me it was an application called ParaCloud Gem. Do you remember that?
I
I
do,
mean,
yes.
it was like, whoa, this is incredible because now I can have, I can basically define a loose framework of cells that is morphing or changing along a spline or whatever, and then it's going to pack those cells with whatever geometry,
Yes.
and I can further manipulate how the cells like squish or taper or do these things as they're moving along this. And that was like, whoa, just like you said, super transformative and
Yes, yes.
just the possibility of what you could do with 3D geometry and
Hmm.
design.
Yep, absolutely.
I don't know what ever happened to that program, but yeah, I think the last time I tried to look, it's still those kind of initial release videos, and then it just
Yes,
kind of
yes.
went away. There
Yes.
wasn't enough user
Right.
base for something like that on
Yep.
the Mac side back then.
Yep. Yep. Well, was it only on the Mac or was it also available? Because
That's what I remember. I don't
I
remember. I don't know for sure, but it
right,
was the only thing available to me.
right.
So
Because I
on the
remember
Mac.
that, and I don't remember it if I just knew about it or if I was actually,
Yeah.
testing it out. But I do
Yeah.
remember that.
I remember the stuff also. It wasn't long after that that Raja was doing at McNeil with, and the name is escaping me right now, but paneling tools inside
Yes.
of Rhino, right? It was
Hmm.
kind of a similar idea where it was like define these cells, these grid cells, and then you can
Yes.
pack them with various
Yes.
geometries. It was really
Yes.
cool. Yeah. Yeah, I got to speak with her once. It was at an Autodesk University. We just happened to sit down at the same table for breakfast, and I didn't know who she. I mean, I knew the name, but then
Right.
we just started talking, and she's like, "What three? You know, I used Form Z. I was a big Form Z user
Ah,
back in the day."
yes. Hmm.
And she's like, "Oh yeah, I use Rhino," and then I find out who she is, and I'm like, "You don't just use Rhino." Yeah. Incredible person. Yes.
Yes.
Well, I'm really interested to kind of see what you think now about like with technology in architecture. I mean, you've experienced it all, literally from the Atari 800 up
Hmm.
until where we are now with a new AI tool every 6 hours.
Hmm.
There's a lot that's changed, but then fundamentally, architects, I think overall are cautious and
Yes.
slower to adopt a lot of these things. But it sounds like SOM has been ahead of that curve for the most part in a lot of ways. What are you excited about with architecture? What are you not excited about with technology and architecture? I mean, from your point of view, you're the oracle as far as I'm concerned. What do you think
Um,
is what's going on that's good? What's going on that's bad?
yeah, I'm pretty optimistic. I think, people are asking me about AI, and I'm afraid of AI, and I think it's going to be an amazing, transformative tool that we'll be able
Mm,
to use. Um, I think personally, I've been a little bit hesitant to jump in, because some of the tools that I've been watching um, are not really doing things that I'm so interested in, like a lot of
mm,
the visualization tools.
mm,
I mean, I've done renderings in the early days, but not so much anymore. Very interested in what it's able to do. I mean, looking at these results, and it's unbelievable, and how quickly they can be generated.
yeah.
But more interested in using these kinds of tools to generate models,
Hmm.
to figure out geometry, to ask a question, um,
Hmm.
to
Yeah.
a
I
to a
mean,
tool.
we
Right?
both got to attend the AEC Tech
Yes.
Conference in New York
Mhm.
City. Was there something there as far as that really stood out to you that you thought, oh, like interesting use case? Oh, I didn't think about that before. Or, do you just see this more as an evolution of thing where we've been to where we're going?
I see new things coming out, and it probably is an evolution,
Hmm.
um, not something that just came out of nowhere.
Yeah.
But like some of the tools that work within Grasshopper to, in a window, let you describe what you want the Grasshopper tool to do, and it builds it for
Yeah.
you.
Yeah.
Things
Yeah,
like
it
that.
is interesting that kind of democratization, further
Mhm.
democratization of, I mean, we thought, okay, wow, with access to these tools, we can make some incredible stuff. There's still a big learning curve
Yes,
to those kinds of tools.
absolutely. That's right.
And to be able to reduce that down to a description in natural language
Mhm.
is incredible to be able to
Yes,
do that. And
yes.
but then, so do you have concerns about, I guess, you talk about the optimism in with AI.
Hmm.
When you think about kind of the different generations that are in the architectural profession right now, and think about who's being affected by the democratization of these tools, the theory that's playing out in my head is that for a while there, I was really scared for, not scared, but, just concerned about the older generation, obviously retiring with a lot of information inside of their heads
Hmm.
and not having documented that or mentored or apprenticed, like that, just getting people up to, they can only do what they can do. They can't just mass apply it to everybody who's coming out of school and address the gap of academia to the professional practice. But then I was really just thinking like, okay, well, the younger generation is going to adopt all these tools, and okay, they're going to have access to instant information all the time, right? So if there was documentation, now they have access to it. But now I'm concerned the other way around again, and that is that the people who have been in the profession of architecture for a long time have the experience And we're at the point now where, yeah, you can tell the tool a description and it'll spit something out, but there's only one of those two people actually knows how to get that thing built, right? It's, they have been through it all because it's a complex system. Yes. Architecture, the built environment, AHJs, codes, consultants, liability, risk, insurance, budgets, like you name it. There's a lot going on there. And it's complex. And every site and every owner is a different version of that, right? And so it's through all of that experience that project can be successful, right?
That's
and
right.
So I'm once again nervous for the young people who come to the profession where there are no older generation because they've retired with that know-how, that wisdom, not the data, not the knowledge, not the lower level versions of information on the hierarchy, but the wisdom.
Yes.
And so that's what I'm tumbling around in my head. Have you been thinking about our profession and these different levels and the way the tools are going to be applied?
Yes. So we have a couple of programs at the office to sort of help with that. And we probably need to do a lot more than we're doing. But we started this program called Masterclasses, where we have people with that experience teaching younger people. These classes are actually open to anyone in the firm. So it could be someone who's just starting or someone who's been there a while, about things like how things get built, how to properly document something, right? Even if you're using AI, right? You still need to check it and make sure that what's going out is something that works. We also encourage people to visit sites and actually see how things are built. And when I was in Chicago for a number of years, and there was a time when we were doing a lot of work overseas, but not much locally. And thought that one of the missed opportunities is that there aren't building sites that we can send people to learn about those things. In New York, we're actually doing a lot of building, so that's more possible now.
Yeah, I'm glad to hear that you're doing that and being proactive about that, because I think for a long time I've also witnessed like that lack of real connection to the work of, okay, what did the line
exactly,
what meant when you drew that line versus what actually happened are sometimes two very different things. Like I had no idea. I didn't like you explaining a reflective ceiling plan to somebody who doesn't know what it is, and they're like, what are you talking about?
That's right.
It's an interesting conundrum because like you have to be drawing and doing the billable hour kind of a thing, and then but that connection is so important to the real work. It makes me think that the liability, the legal architect title / license registration is going to be more important than ever. But then it makes me think that the licensing bodies in our professional organizations also need to step up and really be addressing that, because we talk about the future of this profession, and it's like, well, if anybody can describe a design and the machine's going to output the design, like people are just going to go ahead and try to build it. So where do the checks and balances around liability and all of those things really start to come in? And I think that's where there has been a kind of a lull in the profession, at least from my point of view of people pursuing licensure. At least there was for a while. It might have started to jump back up, but that is going to be more important than ever, I think.
Yeah, I agree, absolutely. And we're really encouraging people here at the office to become licensed.
Yeah, important for an individual's future, I think, to finish what they started by going to architecture school and getting through that, so that yeah.
At SOM, it's required actually to be promoted up to a certain level. You have to have your license. When I started at SOM, people always used to say, "What do you need that for?" At that time, that wasn't the case, right? You didn't. You could still be promoted without a license. But I always thought it was important, and sort of dismissed people who said, "Don't bother, it's not worth it." Even though my focus was something other than maybe the typical architect. I was always interested in computational design, but I thought it was important, not just to get a piece of paper, but to prove that I'm able to, you know, I'm an architect. I know all this
Yeah.
stuff.
Right. Yeah, absolutely. Are there any, final parting thoughts that you'd like to share? I was just thinking it might be interesting if there was anything that really stands out to you in your career. Maybe it was a project, maybe it was, I don't know. I don't know what it could be. Maybe it's a technology, but something in your career that is like just like a top highlight that you would love to tell me about.
Yeah. Um, well, a couple of things I mentioned. One of them is just this concept of uh, designing the behavior or designing the
Mm-hmm.
rules, and then being able to use tools, right? Even if it's your mind, but computational tools to realize that, uh, to see something that you didn't expect
Mm,
is what excites me the most. Here's the
yeah.
rules. This is what you're showing me is possible based on those rules. And then to be so inspired and surprised by what I'm seeing. Um, and that happens once in a while.
Well, yeah, I was going to ask you, can you think of an outcome like one you're describing, different
Right.
than the school that you did that you were
Right.
just really struck by? I mean, I think about like James Turrell's
Yes.
sky space
Hmm.
installations,
Hmm.
right?
Yep.
As the kind of example of what you're talking about. It's like
Yes. Mm.
it's mind bending to go
Yes.
to
Yes.
experience
That's
those
right.
kinds of
Hmm.
things that he's able to
Yeah.
do with light and color, right? It's
Yes.
a
Yes.
very basic palette,
That's right.
but
Yeah.
it to me that's kind of what you're describing. But are there
Yes.
examples
Yeah.
of that kind of thing
Yes.
in the built
So,
environment for you?
yes, absolutely. The second thing I was going to mention was another project that
Okay.
was one of my favorites. It's interesting. My two favorite projects are not skyscrapers. One of them is the school, or, even
Hmm.
just a piece of the school, the skylight.
Right.
Another one is a cathedral that we did in Oakland, California, the Cathedral of Christ the Light. And the building, it's a very contemporary cathedral. And inside the building, there's a sculpture that's metal panels, and they're perforated. And there's a glass window behind them. And the perforations are different sizes. And when you're looking at it, because of the light coming through, it creates this image of Jesus. And I was asked to model that.
Oh,
Uh,
okay.
and yeah, that was uh, an incredible project to work on.
I bet.
And I worked with our graphics department in the San Francisco office. And I had never seen it. It was interesting I love the model that I created, and to
Hmm.
actually be able to create the fabrication files that they were using to construct it was a really interesting process. Then about 2 years ago, I went to San Francisco and was able to visit the building in Oakland for the first time. I was amazed.
Nice.
It's something
Wonderful.
that I couldn't, I've seen renderings of it. I created
Yeah.
part of it, but to
Yeah.
experience that was something else.
Wow. Very cool.
Yeah.
It's I love what you do because you are, I mean, even in these two final kind of projects that you're explaining where it all comes together, that's what it is. It's like it's
Yes.
coming together to affect real people and their
Yes.
experiences in the built environment. And
Yes.
we don't do our jobs so that we get to use these tools. Like we didn't become architects to use these tools, right?
That's right.
We became architects
Hmm.
to change the built environment, to make it
Yes.
better, to have
Hmm.
give people experiences, to get
Yeah.
to better our built environment, and the tools are in service to that.
Yes.
And I think a lot of times, there's, especially with all of the fury around AI and stuff right now, it's like that conversation is backwards
Hmm.
to
Yes.
a huge extent still. It's like because the tools. It's like no, not because of the tools. It's about the people, and
That's
I think that's a really wonderful thing about being an architect is
yes.
that you get to have a
Yes.
hand in that. But
Hmm.
also, I mean, it just really comes through in the story that you just told. It's
Hmm.
like
Yes.
even you not getting to experience it for so long and then getting to experience it, even though you had experienced it in ways that no one will ever get to, leading
That's
to that point. But then you
that's
had
true.
that final that experience, and that's really cool
Exactly. Yes.
to hear about.
Yep. Yep. And another aspect of what I do is more theoretical. So I'm still into morphology and geometry, and in fact, still working with my professor who I now teach with, in doing research in various very abstract geometric forms. And, you think that it's all been discovered. It's not true. There's so
Mm,
much more to learn and to
very cool.
explore. And it's similar also. I mean, it's not the tool, but it's what comes out of it.
So you're teaching at Pratt.
Yes.
Do you have, like, is this documented? Are you putting together a book? Is there a way that people can see the kinds of things that you're talking about here for themselves?
Well, the program at Pratt that I'm teaching in is called the Center for Experimental Structures, CES. And on the Pratt website, there's a page about that program.
Okay.
Right now, we're looking at minimal surfaces,
Okay.
so exploring them. And most of the students are actually creating physical models.
Oh, nice.
I'm working with them to develop grasshopper tools, for example, to explore some of these shapes. But we're also using physical models to look at them, to research them.
Wonderful. Well, I'll put a link to that in the show notes so people can check that out. Neil, this has been a wonderful conversation. Thank you so much
For me too. Thank
taking the
you.
time out to do it. Yeah, I mean, we covered a lot of ground today.
Yes.
That's for sure. Decades worth of things, and I'm
Yes.
sure we missed a lot of details, but this has been a really fun conversation to have
Me
with you.
too.
I appreciate it.
Thank you very much. I appreciate it.
Thanks to our sponsors, and thanks to our members this week. Find out how you can become a member at trxl.co, and I'll talk to you again next week.